Let's say we wanted to provide our API with the ability to return all of the orders grouped by state. So we can do that pretty easily here. We'll create a new HTTP GET method, and we'll call this one by state. So then we'll have a public iAction result by state here, and we'll grab our orders, which will go to our context.orders, and we'll be sure again to include the order customer. .toList. And then I'm going to store a variable for our group result here. So I'll give us a little extra space here, sorry about that. So we'll have a group result. And so now we're going to use link to do some grouping here. This would be like this would be analogous in SQL to doing a group by if you're doing a type of sort of aggregate query. Right here, what we can do is say orders and then group by, and this is really useful. We're going to group by the order.customer.state, and then we'll call toList. And then from this list, what I'm going to do is select, and with the select, we can just select our grouping into a new object. So we have our grouping, and the object that we want to return has a property state on it, which is actually the group key, because that is what we just grouped by. And it's got a total value, and this is where we would use some aggregate method, in this case like sum. So we're going to go ahead and sum the result of the grouping, and specifically we're going to sum the order total. Okay, so that's pretty cool. And we'll finally just order the final result here by descending, and we'll order it by the descending value of total, and then I'm going to call toList here as well. Finally, we'll return an OK response with our grouped result. So just to kind of recap what's happening here once more, because we went through that rather quickly, we're getting all the orders from our system. We're explicitly including the customer navigation properties on those orders. So every order has a customer, and that customer is a complex object that has a state on it. So we need to include the customer in order to group by orders by state. And then we just call toList on that. I found that was necessary here. Otherwise, if I didn't enumerate to a list here, I got an entity framework error previously. So just a side note there when using group by. And then I have this grouped result variable. So we take these orders that we got back that have the customers on them, and then we can use link group by to group by some property on that set. In this case, we choose the customer state properties. Call toList, so we have that object in memory, and then we select a new object out of that query result there. So that object has two properties here, just the state and the total number of orders. And we get that by grabbing the key off of the grouping, which in this case was of course grouped by state. And then we sum the total number of orders by summing this total property, which is on our order model. And so we sum all those values for that particular grouping, and then we order that entire result by the total. So we should have a descending list of states and the total number of orders for each of those states in order here. So then we can go ahead and return that with an OK response. Likewise, we could write a very analogous method here to return orders grouped by customers. Let's go ahead and I'm just going to copy and paste this method. We'll call this one by customer. We still want to get all orders and include customers. This time we're going to group by the customer ID, however, and we'll return an object that has the customer name, which will be not the group key in this case, that would just be the customer ID. So what we can do here is take a look in our context for customers, and we'll find customers that have that ID and then grab their name. So that's how we grab the name given the customer ID as our grouping. And once again, we'll sum by the total property on our orders, order by descending of that total, and then put that out to a list here. We could also change this up a little bit so that we basically pass or request a certain top number of customers. So we'll do that by passing in an integer n here. And then before we call toList, we can actually just take n results. And so now we have a simple way to say grab the top 3 customers by sales volume. Okay, likewise, we'll once again return an OK response with our grouped result. And then finally, let's go ahead and just build in the ability to get an order by ID. So we'll have HTTP get, and this will be like get order, and we'll give this one a name, get order. So this time we'll return an action result, get order here, and we'll pass it an int ID. And here we can simply return context.orders.include customer to include the customer on the orders again, and we'll return the first where the order ID is equal to the ID that we pass our route or with our route. So, and we don't want to actually return that directly. We'll store that as the order, and then we'll return OK with that order result. All right, so I'm also just going to clean this up a bit here. And so now we have a method to get an order by ID. All right, I'm going to go ahead and make a commit here because it's been a little while, and as I'm working through the course here, narrating the code, I don't think to make commits quite as often, but you should probably make commits more often than I have here. Let's check the status. So we've done quite a bit. We'll add everything here, and we create pagination or paginated response, add customer order controllers. Okay. Let's go ahead and use .NET Run and check out the responses that we'll get back from our API. All right, so everything is running. So let's go back into localhost 5000, and we'll visit /API/customer. And this time, we'll test them out in order here. So I'll move the browser over to the right, and we'll take a look at the various methods that we've created. So first of all, let's visit API/order, and then let's check if this paginated response is working. So let's get the first page with 10 orders per page. So first page, in other words, page index 1, and then page length will be 10 orders per page. Okay, so we're getting an exception here that says route creation exception. The following errors occurred with attribute routing information for action get order. The routing parameter name, double quotes, here is invalid. So route parameter names must be non-empty and not contain some special characters here. So let's go take a look at our get order method and see what we've done incorrectly here. We'll come down to get order. Obviously, I've left out the ID here in our attribute. Okay, so we'll go ahead and stop the server and restart it here. And once again, I'll move the code off to the left side of the screen here. And we'll try once again to hit our API here using the first get request route here, where we're getting the page number and page size. So first page with 10 results per page. So we can see that here we have this page object that contains a total number of results that we have in the database, and then the data should contain 10 of the orders that we have here. So it looks good, and we also see that we have this total number of pages, which is 100. And that makes sense because we are getting 10 results per page, and 100 times 10 is 1000, which is the total number of results in our database. Likewise, if I want to get the first page of, say, 2 results, we can pass the route 1/2 and see that we'll have 500 pages. And if I wanted to get, say, the second page of 2 results, we can paginate through the orders in our system in this way. Okay, so the next route that we can examine is by state. So let's go ahead and just run order/by state. And now you can see an ordered list of orders by state. So we have our grouping here that is on the 2-letter code for the US state, and then we have the sum total of order volume for that state. So these numbers should be descending, which looks good, and looks like that is our total response. Likewise, we can now run by customer, and we'll pass, say, looking at the top 3 customers, for instance. So now we see a top 3 list of customers by sales volume from our database. Likewise, if we wanted to do the top 5, we could run it again, passing a route value of 5 to our API. Finally, we should have the ability to just get an order by ID. Since we have 1,000 orders, should be able to pass it ID 571. Likewise, we can use this get order. So let's say order/get order, passing it an ID of 5 here, or since there are 1,000 orders, we could pass it 571, and once again get a result by order ID from our data. So that's pretty cool. You could write additional methods here to do simple things like check whether an order is completed, returning a true or false value. You could write methods to return individual properties from a particular order ID or a customer, that sort of thing. We'll keep it at just these few methods for now, and these will allow us to create some interesting data visualizations on the Angular side of things a little bit later in the course. Okay, so let's go ahead and close the browser, and I'll stop the server for now. And we'll take a look back in our file explorer here and create our final controller, the server controller. Oops, and this of course needs to be servercontroller.cs. So we'll use the namespace advantage.api. Once again, we'll have our route attribute here. We'll have route, and we can visit it at API / the name of the controller. And we'll define our public class server controller here, which will extend controller. For this, as usual, we need to bring in ASP NET Core MVC. And once again, I'm just going to actually copy and paste this time the context field and the constructor, which we'll need to rename here directly in our server controller. So we have our private read-only API context. Here we'll have server controller, and we'll go ahead and bring in our models namespace. All right, we're just going to keep it relatively simple here for the server controller. We will still have the basic HTTP GET method. And we'll go ahead and store a response as a var, and we'll look in our context for servers, and we'll just go ahead and also explicitly order these by using system.link. We'll order these by the server ID. And then return an OK with the response. Now we'll build the ability to get a server by its primary key. So here we'll pass it an ID, and we'll name this route get server. And so the overload here will take an ID. And here all we need to do is call find and pass it that ID. And return an OK response with that. And now what I want to do is something a little bit more interesting. Is we're going to create an HTTP put method. We'll pass this in ID. And we're going to use this to update a server. So we'll say public iActionResult, and we're going to call this message. So we're going to send a message to our server object. int ID, and then from body, just like we did for the post method in our customer controller, we're going to create a special type server message that will send up to or with our request. So let's go ahead and create a server message model. It's going to be relatively straightforward. I have our public class server message, and this will have an ID on it, and then we'll have some public string payload here as well. We should also probably have like a date time that the message was sent, but just to get it working, we're going to keep things very simple here for the time being. So we have this server message class. I'll go ahead and close this, and we'll close some of the other windows that we don't need as well. So I'm going to have this put method. So the put will be used to update an entity, and basically the put sort of requires us to supply all the values for that entity which we're updating. We could also use a patch here if we just want to particularly target some property, but we'll be using an HTTP put. And let's go ahead and target the server that we'd like to update. So server, we'll look into the context for our servers and go ahead and get the server that has the ID that we passed this method. And if that server is null, then we can actually return a not found response. Okay, otherwise, assuming that the server is found by its ID, and this is something, I'll make a note here that we might refactor, and we'll move the following methods into a service perhaps. But what we'll do is we'll say if the message.payload, the message that we're sending this server, if the message.payload is equal to activate, then we're going to update the server status to be online. And we'll go ahead and save changes. Otherwise, we'll say if the message payload is deactivate, then we'll update our server to be offline. So is online false. And again, we'll save changes. We could probably move save changes out here outside of the if blocks, so we only need to call it once. And here we don't need to return anything necessarily. If you don't want to return anything, then you can return a new no content result. Okay, so if you were, say, actually writing some code that interacted with real services or real hardware, and weren't just representing them in a database here with is online statuses of true or false, then you might move all of this logic into a service and then handle the queuing off of some type of message that gets sent to a queue or something that actually controls the actual status of some service or hardware. We're just kind of representing it here in this Boolean is online value of true or false, and just looking at how we can use an HTTP put method to update some data in our database and call some code. So, but as I said, if you had some actual backend services or servers running that you could interact with via some code, then you might have a put or a post method as an entry point to kicking off that process here. Okay, let's see if we can kind of get this working. So we need to kind of know the structure of what we're sending. So we need to send up an int ID and a server message here. So we'll fire up Postman, and let's go ahead and try to hit our route API /server and then /the ID as a put method and send it up some payload. So I'm just going to create a new request. Let's just call this put request, and we'll keep this with our other collection. And of course we need to go ahead and start our server as well. Okay, so let's construct our request. So we'll make a put request, and we'll visit localhost 5000 /API/server in this case, because we're working with the server controller. And let's go ahead and send a message to the server with primary key 1 here. And then in our body, we'll just write out some JSON. where we'll say the ID is 1 and the payload, the message payload here, is deactivate. So let's go ahead and send up this put request. So we got our 204 no content result back. If we take a look in our Postgres database and select star from servers, and we can just do where ID is equal to 1, we can see that is online is now set to false. So just to confirm, let's send up a put request here with activate as the message payload. We'll send this up, get our no content result, and if we head back into the database and run our query again, we can see that the database has been updated to provide an online value of true for the server where the ID is equal to 1. Okay, so that completes our simple web API. I realize that was probably a lot all at once if you don't have much C# experience, but this should be a useful starting point for a general purpose sort of development API that you can use as a backend to not only build out the Angular 4 dashboard application that we're building in this course, but for any future types of front-end apps that you're building. So very quickly, there is one more thing that we need to do in our API, and that is to handle CORS, or cross-origin resource sharing. So an example of a cross-origin request would be like when our front-end application, when our Angular application is getting served up from one server on some domain, and then our API is running on a completely different host, from a different port. So we have these two separate servers running on separate domains, and we still need the ability for Angular to make requests out to our API. So for security purposes, most browsers are going to restrict that communication, which is your cross-origin HTTP requests, when they are actually initiated from within some script. And that is unless we provide some CORS headers. And so CORS is meant as a way to basically secure those cross-domain requests and data transfers. So we can set that all up in our API code here directly in our startup class. So for development purposes, in our configure services method, what I'm going to do is basically maybe at the top here of the method here, we'll say services, and we have the ability to add CORS. And we can specify some of our options here, and we're going to make them very broad and very lax, just for the purposes of our development. So on our options, we can say add policy, and we'll name the policy here as our CORS policy. You can name it whatever you like. And then we can define our policy here. So you can see that we have lots of different options here. I can say things like allow any origin. We'll allow, if I can get rid of IntelliSense here, which is pretty annoying. We can allow any header. We can allow any method. And you can do things like allow credentials and that sort of thing as well. But for now, we'll just allow any method and allow any header. Oops, and there's our closing parens there. Sorry about the IntelliSense, that's pretty horrible. So we'll try to make that go away. And so here's where we add a CORS policy to our service collection, and then when we configure the app at runtime, we can use that particular CORS policy. So we'll say if the app environment is development, then we can say app.useCORS policy here. Okay, so that's relatively straightforward. Basically, we just define a very lax CORS policy allowing any origin with any header, any method, and then when our application is running in development mode, we'll use that policy. If we were going to deploy our app, and in the future I would like to create an add-on where we deploy this app to Heroku, then we might have a more specific CORS policy where we allow CORS depending on the particular origin that the request is coming from. Okay, so that should more or less wrap up our web API. We'll come back here if we need to make any more changes to it, but at this point it should suffice for us to actually complete our Angular 4 application. Our application is relatively simple. There's definitely some refactoring that we could do here. Certainly if it were a larger project, we would have more projects here with different class libraries and better separation of concerns. but as a sort of debugging tool, if you will, a basic API that we can build front-end applications on. It will actually work pretty well. So I hope that you got something out of this part of the course. In the next video, we'll jump right back into Angular 4 and start writing the code that actually makes requests out to our API here and creates some visualizations with real data as opposed to the hard-coded data that we currently have in our Angular app.